Today we're doing section 6.5, least squares problems. The most important aspect of least squares problems is no matter what x we select, the vector x will necessarily be in the column space, column A. So we seek an x that makes ax the closest point in column A to B. Least square solution. If A is an n by n matrix and vector B is an Rn, at least a least squares solution of ax equals b is an x hat and Rn such that the length of b minus ax hat is less than or equal to the length of b minus ax for all x in Rn. So vector b is closer to ax hat than to ax for other x values. The solution of the general least squares problems. Theorem 13. The set of least square solutions of ax equals b coincides with the non-empty set of solutions of the normal equation A transpose ax equals A transpose b. Example 1. Find the least square solution of ax equals b for a and b. To find the normal equations and to compute x hat, compute A transpose A and A transpose B. So let's first compute A transpose A. So A transpose would be 2, negative 2, 2, 1, 0, 3. Two, negative 2, 2, 1, 0, 3. And when we multiply these, we get 12, 8, 8, 10. Then we need to find A transpose B. And you get negative 24, negative 2. So first we need to find our normal equations. And those are in the form A transpose AX equals A transpose B. So that would be 12, 8, 8, 10. And then we need to compute X hat. And to do that, X hat would be A transpose A inverse times A transpose B. A transpose A inverse would be 1 over 56 times 10, negative 8, negative 8, 12 times negative 24, negative 2. This would be 1 over 56 times 224 over 168, or not over 168, excuse me. The matrix 224, 168, which reduces to negative 4, 3. So the least square solution for this would be negative 4, 3. Theorem 14. The matrix A transpose A is invertible if and only if the columns of A are linearly independent. In this case, the equation AX equals B has only one least squares solution, X hat, and is given by X hat equals A transpose A inverse A times A transpose B. When a least squares solution X hat is used to produce AX hat as an approximation to B, the distance from B to AX is called the least squares error of this approximation. Example 2. So in alternative calculations of least squares solutions, find the least squares solutions of AX equals B for this A and B. So because the columns of A are orthogonal, the orthogonal projection of B onto column A is given by this. So these columns in A are orthogonal, and our orthogonal projection of B onto column A is given by B hat, which would be B times or dot A1 all over A1 dot A1 times A1 plus B dot A2 all over A2 dot A2 times A2. A dot or B dot A1 is 8. A1 dot A1 is 4. And that's times A1 plus B times B dot A2 is 45. A2 dot A2 is 90 times A2. This would be 2 times 1, 1, 1, 1 plus 1 half times negative 6, negative 2, 1, 7. And this would equal negative 1, 1, 5 halves, and 11 halves. So now what we need to do is we need to solve AX hat equals B hat. So X hat is 8/4 and 45/9. 45/90, excuse me, which is 2 1/2. Because the weights to be placed on the columns of A produce B hat. Given an n by n matrix A with linearly independent columns, let A equal QR be a QR factorization of A in Theorem 12. Then for each vector B in Rm, the equation AX equals B has a unique least squares solution given by X hat equals R inverse A transpose times vector B. Example 3, find the least squares solution of AX equals B for A and B. First, we need to find the QR factorization of A, and that can be obtained from using the methods in section 6.4. So A equals QR. So I'm just going to give you QR. We're not going to go through and do this, and you can go back to section 6.4. So it would be 1/2, 1/2, 1/2, 1/2, and negative 1/2, 1/2, negative 1/2, 1/2. R ends up being 2035. So now we need to find Q transpose B. This is Q, this is R, we have B up here. So Q transpose B, which is 1/2, 1/2, 1/2, 1/2, negative 1/2, 1/2, negative 1/2, 1/2. B is negative 1, 6, 5, 7. When you multiply these, you get 17 halves and 9 halves. From here, we need to find x hat, which equals R times X, which equals Q transpose B. So R is 2035. X1, X2 equals 17 halves and 9 halves. So go ahead and solve this matrix. And when you do, we would get about 2.9 and 0.9. So x hat is 2.9 and 0.9 is the least squares solution to AX equals B.